the Brussels region, together with the private investor and the tech communities of Brussels, came together to and decided that it was high time that tech communities would have their own home, their own roof, and their own rules on what they wanted to do. So they decided to give us this space. We signed the lease last week for 9 years, so it's a long-term project, and it's a warm invitation to all the communities like yours to come and use the place. We will make sure that whenever you use the place, you can also use the streaming possibilities and every modern possibilities that you would expect at community events. Upstairs, you will see that there is a nice space. We have a rooftop. When there is sun, it's nice to have to have a party there or to relax there. This is a place for communities in 4 different areas of technology. So we are thinking of the data and artificial intelligence area. We are thinking of the virtual reality. We are thinking of the blockchain community and also the IoT community. So the main communities that you can find back in the Next Tech project of the Brussels region are represented here. Myself, I'm the mayor of the data science community, created the community 3.5 years ago. We are now 3,000 people. We did over 100 meetups. We kind of have the habit on how to organize a meetup now. We also organize with our team the Data Innovation Summit, which is a yearly event where about 500 data scientists join with each time more than 40 presentations. And last year we started to add parallel sessions to that, so that you could also have a 2-hour introductory course on different technologies as well. This year the event will take place end of May, beginning of June. We are still negotiating for space. It will not be a 1-day event based for Belgium, but it will be a 3 days event for a European event, and we will add all the other communities as well. So that's the biggest challenge for the coming 12 months, is to organize. And we will not call it Data Innovation Summit anymore. We call it the Brussels Digital Week. Sounds like familiar, but we are going to hack the name anyway. So warm welcome. Why did we get the space? We got the space because the idea of having people driving the sharing and the knowledge sharing was more important than having companies driving it. So if we have a place where communities can gather and that we have like that grassroots energy coming up, where people want to share that their knowledge, it's always much more effective than when you are sent to a course. But the second area is that we are promoting entrepreneurship. So this is also a space for entrepreneurs. The idea is a co-creation space. So because you have different technologies, you could gather here for free. The ground floor is always for free. Everybody's welcome for free here. But you can then start to try, if you are thinking about creating a company, meeting different people and so on. On the entrepreneurship level, we will also have regular information sessions on the different areas like human resources, how to build a financial plan and things like that. This will take place here as well, and on a specific day of the month. And you could then come back, and that will also be Prodeo. So we'll have Prodeo legal advice from the legal hackers and so on will be here every month. So that's basically, our last mission is a more social and inclusive mission that we have. We want to make courses available to anyone who is passionate about it, and certainly people from the Canal region. You know, it's a quite difficult region to be at. So, for example, with the Koning Boudewijn Stichting, we are working on a project Boost, where we allow students, from the first years of university students from the Canal to come and study here during their exam period, which is a much more comfortable area than the kitchen table with the 7 or 8 brothers and sisters fighting and things like that. So that's one thing we are doing. And we, as a data science community, will also coach the students in maths, in statistics, and logics. So these are the 3 areas that we have chosen to coach them when they are coming here. So that's all what I wanted to say. It's a place for learning and sharing. So when you have an idea of something that needs to be shared, we will make sure that you can do it. We have training rooms available from 10 people to 50 people, so you can use that. If you share it for free, you can use the training room for free. If you share it because you want to make money out of it, and that's okay, we will do the principle of shared revenue, where we will keep part of the revenue for us, depending on the level of investment that we do in here. Okay, so have a good evening on the machine learning, Azure Machine Learning. We recently did some certification on Azure Machine Learning with the guys who are preparing themselves to become data scientists here. We are running a data science bootcamp starting October the 2nd, and in order to be accepted in that data science bootcamp, the youngsters needed to certify themselves in different technologies. Azure was one of them, but also R, Python, SQL, and statistics with R and statistics with Python. So I think this is really worthwhile looking at, and I wish you a very good evening. Thank you very much.
Okay, good evening, everybody. Let's get started with this. Let's see what's going on over here. Okay, so welcome to this evening session on our Azure Machine Learning. Let's briefly introduce myself. My name is Nico. I studied computer science at the University of Leuven. And while doing so, discovered that machine learning is super for people who are lazy. Like me, any developer tries to be lazy. You do a lot of work to automate something. Well, what if we can automate the automation? That's more or less what machine learning is about. So I spend a lot of time to make sure I have to do a little programming. That was till 2004. After I finished my PhD over there, I joined UTU, training company here in Zellik, Brussels, where I became the SQL Server guy, because in 2004 BI wasn't as big as it is right now. But then over time the BI suite grew, so I'm now also the Power BI guy and the Cortana Intelligence guy, the R in Visual Studio and that kind of stuff. If you want to get in touch, if you would have any questions or you want to get in touch with me, you find my email address, nico@utu.be. And if you're on Twitter or LinkedIn, I'm SQL Waldorf over there. I'm one of the two grumpy old guys at the Muppet Show. Okay, so this talk is part of the Cortana Intelligence story. On the first Cortug meeting, somebody explained the whole story, where you have data coming in, data that we store, data that we're going to analyze. And if you have a lot of data, of course, you need to find patterns in there. If you know a lot about the past, you hope that this knowledge about the past can also be used to know something about the future. So that's where the Azure Machine Learning fits into the story. Okay, so what do we have on the agenda? First, a little bit about machine learning. Quick show of hands. Who already used some sort of machine learning stuff over here? Okay, that's about half of the audience. Okay, so then you already know what machine learning is about. For the other half, a bit of an introduction to machine learning. Then we get started with our Azure Machine Learning. What do we need? How do you create an account? How do you upload data? That kind of stuff. Now we will see that there is much more than modeling. So we need to pre-process our data. Then we can do the actual modeling. And then once we have this stuff, we can go ahead and try to put it into a real application. That's our last part of the story. Okay. First, a bit about machine learning. This is with which I started my career in IT 33 years ago, a Commodore 16. We had 12 kilobytes of memory in that thing. So when you were programming over there, life was very easy. You could not write much code. But a few years later, I moved on to an Amiga. This thing had 0.5 megabyte. That was huge. So huge that if you start writing programs, you had to take care. You could not just write everything in one single chunk of code. You had to break things apart in methods or procedures who do something, like putting something on screen or writing something to file. And on the other hand, we needed functions. Functions who take a bunch of inputs and from that compute some output. For instance, you have a bunch of values that were provided in a form, and this thing verifies whether these are valid values. No, you cannot have negative quantities for an order or whatever, that kind of stuff. Well, machine learning is, as already mentioned a few minutes ago, most of machine learning, not all, but the type of machine learning that we're mainly going to cover this evening over here, is mainly just trying to learn from a whole bunch of input parameters that you gave to a function, and the result that the function returned, to go ahead and learn from there how to implement this function. So instead of having to program a function, you just show your machine learning, hey, with these inputs, I expect this kind of output. Now go ahead and build a function yourself that goes ahead and does this. That's more or less what supervised machine learning is about, and that's the topic of this evening. Okay, so we program a system that learns this function itself. Great, so you can be lazy. You just need to go ahead and, for instance, say, hey, here are 20 entries for this form. These 5 were no good, the other 15 were good, and the system will try to find patterns and learn what is typical for good and bad entries. Okay. The beauty of the system is it's different from a database. In a database, you can also show examples and then run a query to see for a new observation what the database has seen in the past. But this thing can generalize over your inputs. So if tomorrow you call this thing with an input it never has seen before, it can make an educated guess at what the expected outcome should be. Also, if you go ahead and provide some inputs which are completely irrelevant to the thing you want to predict, the system will detect this and go like, this stuff is useless, I'll go ahead and ignore it. Even if sometimes you make mistakes. For instance, when I was at the university, one of the things I wrote over there was a system that learned from your past emails whether you consider them to be junk, very important, or just regular emails. So the inputs were a whole bunch of properties about an email. Who's the sender? How long is it? Does it have attachments? That kind of stuff. And the result was, this is junk, this is good, this is less important. If I, from time to time, mislabeled things, and you feed it into the system, that's no problem. You can go ahead and have a couple of observations that are wrong. If you have enough observations that are right, the system will go ahead and still come to the kind of function that you want. Also, you can have missing values. In the real world, if you take a look into your database, you have a lot of null values where you don't want to have them. Well, you can go ahead and learn even if some values are missing. So machine learning can be very interesting, but there are some problems. Biggest problem is if you use this kind of machine learning, what you get out of it, the model that is learned by the system, is some complex mathematical hocus pocus. So if you had hoped for a nice, easy to read piece of C# code or whatever, sorry, usually you get something like a neural network or a collection of decision trees or whatever, something that human beings can hardly ever understand. So that leads to a problem. Because if we build this function with machine learning, how can we trust it if we can't verify it? If you write normal code, you go ahead and do unit testing and whatever to see that it really does what you expect it to do. You now have this system where you have not the faintest idea how it works. So how can we work with that one? Well, we're used to that. For instance, if I look at my wife, I have no idea how our brains work. I only know it's very different from the way that my brain works. But yet, there is no problem. I mean, I took the longest contract you can ever get with that person. So what you do is you simply first sit together for a few weeks or a few months, and you see how that person behaves, and you're like, okay, seems reasonable. So I cannot see what's happening, but I still trust the system. Well, with machine learning, we more or less need to do the same thing. We build a model, and then we go ahead and test it with some data for which we know what we want to get. And if the system returns often enough things that seem to be okay, well, we hope for the best, and we go with this. So your self-driving car that you will have in 5 or 10 years from now, nobody knows how it works. We just hope that it does the right thing most of the time. Okay, so how do we do this in machine learning? Well, we usually learn from historical examples, and we typically go ahead and split them into 2 sets. One set that we feed into the system to learn from, then it does its learning, and then we go ahead and on the remainder of the examples, we feed them into the system again, now for testing the model, and in that way we can see whether it does the right thing often enough. Okay, a bit of terminology that we will use in the rest of the evening. The function that we're learning over there, we call that the model. The input parameters to learn from are called features. The thing you want to predict is called the label. Training is that job where you feed in training data and say, okay, go ahead and build your model. And then when we have new observations, we feed them into the system again. And now we're curious to see what the prediction is going to be. That thing is called scoring. Okay, so we have a bunch of historical data. We split it apart into training data and test data. On top of the training data, we go ahead and do that mathematical hocus pocus, and out of it comes a neural network, a bunch of trees, whatever. Then we can take our test data and we can go ahead and feed that into the model. So the scoring component will then go ahead and say, okay, this is the outcome. I predict, for instance, that this email is an important email, or I predict that that customer is not going to pay back its loan, or that that customer will churn, or whatever you want to predict with the system. Once we have this model, then life is easier. Well, as soon as we have new data, we just go ahead and feed the new data into the model that we already have, and we get our outcome. Okay. Now, when we take a look at the Microsoft stack, within the Microsoft stack, we have a couple of options to do machine learning. And one option is where we don't know at all how we have to go ahead and, for instance, build these models and how you have to do all this training, etc. Where you want Microsoft to do everything for you. Some of you might have heard of cognitive services. That's a bunch of pre-trained machine learning models. So basically, the only thing you need to do is feed in new data, and the system will already contain a model where you have no control whatsoever on how this model was created. And it will go ahead and do some scoring for you. For instance, let's go ahead and take this one as an example. So within our cognitive services, you have a whole bunch of services over there. For instance, you might know this one. With the emotion API, you just go ahead and feed in an image. Let's go ahead and pick one of the images that I have over here. Where is this? Here, for instance, this one. Okay, so over here we have a guy with a lot of different facial expressions, and the system goes ahead and feeds this into some pre-trained model, and the model will try to predict whether this person is happy or sad or whatever. So if you now go ahead and hover over this, you see like, oh, over here is 98%, this is hard for you to read, this is 98% sadness, or for instance, if we pick this one, over there, we have 37% neutral, and what is the other one? 57% surprise. Over there, 3% fear, etc. So that's an example where you use machine learning and you have not the faintest idea how it was made. You did not need to provide any training data whatsoever. The system did everything for you. Now, we have another type of cognitive services. That other type of cognitive services is the one where you want it to learn something, but you don't know about decision trees or neural networks or whatever. So you want to use the expertise of Microsoft to know how, from historical data, you can build a model. But you need to provide the historical data because you want to make sure that the model learns something that you know about. For instance, you want to make sure that it does not recognize, oh, this is a person and he's happy or not. You want that the system recognizes you. For instance, that the system can recognize and say, hey, that's Nico over there. Or that's Sami over there, or whatever. So then you need to go ahead and train them, like, oh, these are a couple of photos of Sami, these are a couple of photos of Nico, learn from this thing. So with cognitive services, you can also go ahead and feed in your own historical data. You don't know how the system trains, but out of it, in a magical way, comes this model. And you can just feed in new data, and you get some scoring on top of that. So if you, for instance, want to have some fun with this, there is this free application that you can download. It's known as the Intelligent Kiosk sample. So I think it's on GitHub. If you install this thing, you can go ahead and train it in all sorts of ways. I'm not sure whether there is enough light over here, so I hope this thing is now able to recognize me. But for instance, where is this? I have this greeting kiosk. So if I now go in front of the camera, it says, hey, welcome back, SQL Waldorf. Any of you who tries to resemble me can try to stand in front of the camera. The system will say, hey, you're not SQL Waldorf. So this is an example where I trained this system first with a couple of photos such that it recognizes me. Okay. By the way, you have a lot of nice demos into this tool over here, so you can go ahead and, for instance, get immediate information about how many people and the age of people and all kinds of stuff. So if you want to do demos, nice tool. Okay, so these are examples where we didn't have to tell the system at all how to learn. The system just learns from either data that Microsoft gave it or data that we go ahead and feed into the system. But over here this evening, I mainly want to focus on the third scenario, and that's the scenario where you do the whole thing yourself. So we're going to provide data, we're going to clean up the data, we're going to tell the system how it should do the learning, and then we're going to create web services out of it that can go ahead and test this. Okay, so Azure Machine Learning, you could already guess, huh? Azure, that's a cloud, so it's a cloud-based service. Cloud-based service, that means you don't need to buy hardware, you don't need to go ahead and buy licenses or whatever, you can just get started. It's based on a graphical flow. So I'm pretty far from my keyboard over here, that's not too bad. I will have to type nearly nothing this evening because I mainly use my mouse, drag and drop stuff in there, connect the dots. Those of you familiar with integration services, for instance, will recognize the feeling. It's a lot like the integration service where you connect the dots, configure a few properties, and you're up and running. So you don't need to know about R or Python or any of these things, because once again, it's a graphical way of working. But if you know R, or if you know Google and you can type, find me an R script that does X, you know, copy paste, then you can go ahead and use these skills. So we can extend it with R, we can extend it with Python. If you're in love with a certain Python library to do something, okay, you can just go ahead and upload the library into Azure Machine Learning and use it over there. So it's not that you're stuck to just the GUI. If you prefer, oh, we're getting up close now, yeah. If you prefer to do things textually, that's possible. But if you don't, you can go ahead and use the graphical. And then one of the things that I really love about this is it's super easy to go ahead and deploy this. Some of you already know machine learning. Some people who use R over here. Yeah, Python. Oh, okay, well, so let's pretend you made this nice R script over here. It does exactly what you want it to do. And then some Delphi developer knocks your door and says, okay, I want to integrate what you made in R in my Delphi application. Are you up and running 10 minutes later? I don't think so. That's the problem. How do we go ahead and take whatever you made in R and integrate it in whatever application you have over there? Or some BI person who has no idea what machine learning is says, hey, I love Excel. How can I call your Python or R script in my Excel? Oh, yeah, okay. So these are the problematic things. And with Azure Machine Learning, we literally click, well, two buttons, and we have a web service. A web service that you can call from within Excel. A web service that you can call from, yeah, within every programming language that can call web services. That's any modern programming language. And you're up and running literally in 10 minutes after you finished your model. Nice as well is you don't need to have an Azure subscription. You don't need a credit card or whatever. You can go ahead and use these things completely free with some limitations. And if you really want to go ahead and put something into production, yeah, okay, then you have to pay for it because the limitations will, of course, block you from using these things in production. So the most important thing is it's easy to get started with Azure Machine Learning. And there's a very good reason for this. Because we're over here because we love machine learning and we hope that our boss will let us do some machine learning projects because it's cool, but your boss has a different opinion on that. He only wants to do machine learning because it gives some profit to the company. So some machine learning projects are these super expensive projects where you hope to have a huge return on investment. For instance, if you are the first to have this self-driving car, okay, that will take a lot of effort to build this thing, but probably you'll make a lot of money from it. I have to disappoint you, the majority of the machine learning projects are not like that. Usually, you do something much more stupid. For instance, we need to predict how many bottles of water we will sell next week. We currently already have some sort of model that we use to order enough bottles of water to have them in our shop. But maybe we can improve upon that one. Maybe with machine learning, we can better predict the real demand. And because of that, save 5% in transport costs or storage costs or whatever. It's less spectacular, but that's unfortunately what the majority of machine learning is all about. Now, if you can come up with some machine learning model over here, and because of that, you can better predict how many bottles of water you need to order next week, and because of this, you save, let's say, 500 euros a month. But to build this machine learning project, you have to make an investment that costs you 3 man-months. I don't know what your consultancy fees are, but you will have, you'll have to make a much bigger gain than 500 euros a month before you pay back the investment of a 3 man-month project with some very expensive machine learning experts on it. But if you can go ahead and build that model that makes a better prediction in 3 hours on a Friday afternoon, then the cost of developing this thing is really low. And even if the gain is relatively small, there is a gain. So to have a return on investment, either make sure you have a huge return or you make a small investment. And that's why Azure Machine Learning tries to be as easy as possible. Because in that way, many people can get started with it. You don't need to have a PhD in statistics to use this thing. And you don't need to be a super great programmer to bring it into production because of that web service trick. Okay, so how do we get started with this thing? Okay, let's go into demo mode. Okay, let's first open up Incognito window. The only thing you have to remember is this thing, studio.azureml.net. I have it on the slide somewhere, and by the way, I uploaded the slides to the Meetup page, so you can go ahead and get all the slides from there. So if you go to studio.azureml.net, I use an incognito window such that he doesn't know who I am. Well, then I hope it loads. I don't know, it's a bit slow. So then over here, there we go, and I have this sign up option. And with the sign up option, we have 3 ways to get started. Option 1, you don't trust Microsoft, you don't want to use any of your Microsoft accounts or whatever, you want to be completely anonymous, then you can use it for free for 8 hours. And in this Mission Impossible style, after 8 hours, whatever you did self-destroys and leave no traces, probably. If you use that one, you cannot create web services, you cannot use R code or whatever. Because Microsoft wants to make sure you don't spin off 10,000 of these free trials and run some Bitcoin miner in R and use their free compute time to go ahead and use these things. Okay, so there are a bunch of limitations if you use that one. That's ideal for instance, if you go to a school and you want to show people over there how to get started. These 12-year-old kids in school, they don't have a Microsoft account and they don't have a credit card, so this is the ideal option for them. If you're more serious about what you want to do, but you don't want to spend any money, or you're going to use this free workspace, that's the one that I will use this evening, then you can create web services. You can run R code, you can run Python code, but with your single Microsoft account, so if you have an Outlook account or whatever, you have a Microsoft account. So with your Microsoft account, you can only spin off one of these things. There are also some limitations. When we're going to create stuff in there, it needs to compute its result within an hour. Any experiment that takes longer than an hour is cancelled after an hour. Another limitation is if you upload data, you can only upload 10 gigabytes of data. Last limitation, if you create web services, you can test them, but you cannot test them in parallel. To make sure that you do not put these things live on a production web page, because if now many people would together visit your web page, most of them will be blocked and only some requests go through. But ideal for a proof of concept, for playing around with these things, etc. And completely free. Doesn't expire after a month or whatever, completely free. The last option is you want to use this in an enterprise setting, then you have to pay. There are currently 2 ways of working. The old approach is you pay about 8 euros a month in your Azure subscription, plus you pay per compute hour and per web service call that is made to your service. Second option, you prepay. You go ahead and buy a package of, let's say, 20 hours of compute time a month and 1 million calls to your web service. And there you have different tiers, different levels that you can buy up front. But the functionality is the same in both of these, and with the exception of the R and Python stuff in that one as well. Okay, so I already logged in mine over here. Oh no, I didn't log in yet. So let's quickly, in my regular browser, go to my studio azureml.net as well. So if I sign in over here, you will know who I am and connect me through. So in your Azure Machine Learning studio, if you want to get started, we must first learn a little bit more about these things that we have over here. The key thing is an experiment. In machine learning, there are no certainties. It's a lot of trial and error, just like it is in chemistry. That's why they use a lot of the logos, like the Erlenmeyer, etc., over there from chemistry. So we need to go ahead and do a whole bunch of experiments. So over here, you see a list of experiments that I've been doing, when I ran these things, who ran them, etc. Experiments, of course, could need data. We'll see in a few minutes how we can get data into the system, but one way is to upload a CSV file or whatever. Those are your data sets. Out of an experiment, you can create a web service. So that's your list of web services over there. If you create a web service that has already learned something, so those are the trained models that are being used over there. For those of you who love Python and R, I have good news. Notebooks over there are Jupyter notebooks. Those of you not familiar with this, we'll see them in a few moments. And finally, you can go ahead and group a bunch of these things together. So a project is like a folder where you have a couple of experiments and stuff together. Okay. So let's go ahead and make this thing a bit larger. So if you want to get started with any of these, you just click this new button, for instance, to create a new experiment. And then I already mentioned, Microsoft wants to make it as easy as possible to get started with these things. So what you have over here is you can create a blank experiment, and that's the one I'll be using a lot. But you have a couple of examples. All these other things over here are ready-made examples. And some of them are the hello world kind of example. But some of them are really big examples on how to do churn prediction, predictive maintenance, and many of these typical machine learning tasks. So one way to learn from these things is, for instance, to just go ahead, pick one of these things, click Open in Studio, and then it copies the sample into your list of experiments. So experiments can be created yourself, or you can just go ahead and borrow from others. And then over here, you have a bunch of things. We'll go over these later on. So that's how you can get started. Either you start from scratch, or you borrow from, more than 100 examples that you have over there. Maybe another thing about these examples, for instance, over here, I have this thing. I have a lot of building blocks in building your solution. For every building block, you have this quick help thing over here. And if you click on that quick help, you arrive at a web page that explains what that particular thing does. So over here you have a multi-class neural network. If you don't know what a multi-class neural network is, you can start reading over here. Often there are links to Wikipedia articles or research papers from Microsoft or whatever that go ahead and tell you more about this. But if you scroll all the way down, you always arrive at these examples. So here you see a list of these examples that I showed you a few minutes ago that use this particular thing. Many people, if they read the manual, they go like, oh, if you could only show me a working example of this thing. Well, over here, you find for each and every component in there a list of working examples that use that particular component. Okay. So, as already explained, we have all these machine learning objects over there. Oh yes, I didn't show you the settings. One of the things you can do with settings is you can invite others in your workspace. Let's pretend that you were busy building something, you're not an expert in neural networks, but you're doing well with your neural network, but then you get stuck at a certain point, and you wish that some sort of consultant could just take a look at what you did so far and help you out for 2 hours. Remember, we have to reduce the cost, so we're not going to hire them for a full day. That's too expensive. What you can then do is you can go to your settings, and in the settings, go ahead and invite others in your workspace. And these others do not have to have an email address in your domain. Could be anybody with a Microsoft account. Then they can get access to what you're doing over there, and after a few hours you disable the access and then they're kicked out again. Okay, so I already showed you the interface, the experiment interface. Now, how do we work with this experiment interface? Let's go back over here and maybe start a new one. So here at the top, I can go ahead and start a blank experiment. So the idea is that you drag stuff from your toolbox over here into this thing over here. Each of the components that you have over here can have properties, and these properties show up over there at the right. So for instance, to get started, you can upload your own data sets. But once again, they want to make it easy on you. So there are a bunch of these sample data sets. Our people are familiar with this. There you have a whole bunch of built-in data sets. So if you fell in love with the iris data set, for instance, we're in Brussels. I think iris is the flower of Brussels, if I'm not mistaken. So let's go ahead and take this one. I can just go ahead, drag this thing in here, and I automatically have some data set to get started with. In Azure Machine Learning, each of these components can have inputs and outputs. Inputs at the top, outputs at the bottom. So over here, we have no input for the data set. Of course, we only have outputs. But if I right-click this one, I can, for instance, choose Visualize and get some ID on the data that we have in here. So I see that we have 5 columns in this data set. I see, for instance, that this one seems to be quite normal distributed, whereas this one is clearly some binary thing. And this one over here, that's more exotically distributed. If you click upon this, you zoom in a little bit on that, you get immediately some basic statistics like mean, median value, standard deviation, etc. You can also go ahead and take a look at them with this histogram. You can choose the number of bins. So for instance, let's go to 20 bins to see whether it still looks normally distributed. Okay, now things change a little bit, as you see over here. You can also go ahead and, for instance, compare it with others. For instance, in this case, we want to predict whether you're a certain type of flower. So the 1 over here means you're one type of flower, a 0 is you're another type of flower. So I can now go ahead and, for instance, compare this thing to the class. And then we go ahead and see over here that if sepal width is on the short side, you tend to have more 1s. If it's on the longer side, you tend to have more 0s over here. Okay, so first easy way to dive a bit into the data, play a little bit with this data. You can also switch over to whisker plots if you prefer those. So in this case, we now get a whisker plot of our sepal width over there. Okay. If you want to do a much deeper dive into this data, you can, as one option, say, hey, just download this as a CSV file. I love R, I will load it in my RStudio or whatever. I really wish they're going to make a connection with Power BI Desktop. I'm a Microsoft guy. Power BI Desktop is a really handy tool to play with data. So it would be nice if you would have streaming access to this data set directly from Power BI Desktop. People need to have things on their wish list, so that's one of the things I'm hoping for. Currently, we don't have that one yet. Okay, but what you can do as well is you can go ahead and open up these things in notebooks if you want. What are notebooks? Well, to go ahead and show you this, I must first convert this thing to a CSV file. So we have in this toolbox a whole bunch of things, so many things that if you would go ahead and start searching in there, you have an endless list of things you can expand, and it takes forever to go ahead and see all these different things that you have in there. So usually if you know the name of the thing you're searching for, or at least part of the name or the description, in this case I want to create a CSV file, you just type CSV. And then over here we see that we have this convert to CSV thing. So by connecting the dots, the output of this thing becomes the input of this thing. I can now go ahead and convert this data set to a CSV file. And if I now run this thing, it will go ahead, read from this thing, and make a CSV file out of that. And then I can download the CSV file, but they have a built-in notebook system. So what are notebooks? Notebooks are just these web pages where you can mix constant text and formulas in R or Python. So if I right-click on this one, and I now pick this open in notebook, I could, for instance, create an R notebook out of this thing. So it now creates a website in which I can type R code. And in this website, it automatically links to the data set that I had a few minutes ago over there. So I need to first execute this code. Don't worry what's in the code. We executed this, and this loaded in R an object called dat. That's probably impossible to read for you. That's maybe a bit better. So it loads in this dat variable whatever is in my data set that I have in Azure Machine Learning. And now I could, for instance, go ahead and say, okay, plot this dat object that I have over there, Control Enter, it goes ahead and you get your plot. Or for instance, you want to go ahead and compute some correlations over there. So you do a cor. And then you see, for instance, that the thing we want to predict seems to be strongly correlated with sepal length. So you can go ahead and take some notes, insert a cell below. In this cell, I don't want to write code, but Markdown. And then, for instance, if you're familiar with Markdown, it's this kind of very simple markup language. First conclusion, enter. This correlates with the, what was it, sepal length. Okay, you want to emphasize this, so in markup you can, for instance, use things like star star to emphasize things. You do Control Enter, this gets evaluated, and there you have your text. So in this way you can build a sort of research report on what you're doing, and then we can download this as a PDF file, as an HTML file, or a notebook if you want to continue working with these things locally. By the way, the kind of code that you have over here, you can also run in your RStudio. If you go like, hey, I don't like notebooks, I want to use my local RStudio, there is a special R library and a similar Python library that allows you to download data from your Azure Machine Learning space right into your on-prem R or on-prem Python. And then you can go ahead and do these kind of things in whatever local tool you have over there. Okay. So as we already saw, we have over here a bunch of things. We drag them in there, we connect the dots. Some of these things have properties, and these properties are configured over there. Let's maybe show an example of that one. So let's go back to my experiments. I, for instance, want to go ahead and split this data. We've seen you need to split your data into training data and test data. So how do we do this? We just type split over here. And then we see a split data component. Okay, drag it in there. I tell him that whatever comes out of this thing goes into this one. By the way, you don't need to build a sequence. You could also say, oh, whatever comes out of this one goes directly into this one. But now if you need to do a split, you need to tell the system how to split the data. So when I click upon this thing, we see that we can split things in a couple of ways. For instance, I can just write a regular expression. Whatever meets the regular expression goes on the left. Whatever does not meet the regular expression goes on the right. Or I can just say, no, give me a random split. I want to have 70% of my data on the left-hand side and the remaining 30% on the other side. Many of these things have advanced options like a stratified split. With a stratified split, we can specify, yeah, I want you to do a random split, but I want in the end that the left-hand side has the same percentage of, for instance, class distributions as on the right-hand side. So with that one, you can go ahead and say split, but keep the distribution balanced like it is, for instance, on the class that we have over here. So you see a lot of drag and drop, a lot of help. On each of these things I can click on help, read a bit about this. So in that way, it's really as easy as connecting the dots, and we learned all that in kindergarten, I guess. So Azure Machine Learning is easy to get started with. Okay. Ooh, did I click on Visual Studio? No, I don't want Visual Studio. Reminds me of coding. We're not going to do coding this evening. Okay. So to train a model, what we need to do is we need to first have a data set in there. We need to split the data. Then remember, we had then some training data. So this thing over here is my training data. We then had to train it. Well, there is a train model component that you drag in there. Out of that comes a model. So this thing over here is your model. Then you have to do some scoring. So there is a score model component. And out of it comes your score data set. That's that thing over there. So the drawing that I made in my PowerPoint really matches what you go ahead and do in your Azure Machine Learning over there. So let's maybe go ahead and show you an example of this. To speed up things, I usually run a 2-day Azure Machine Learning class, and we only have 2 hours, so I need to speed up things a little bit. So like any TV cook, I prepared a couple of things in the oven. So over here I have a couple of examples. So the first over here is a really stupid, super basic data set in which we just have some sort of form. People fill in a number. If the number is less than 18, we claim that it's false. It's no good. If it's 18 or above, it's good. Super stupid. I mean, this is an if then else that we want to learn. I could have written that in 5 seconds, but I'm going to spend 5 minutes to go ahead and learn it. So my age is normally distributed. This thing is distributed this way. Okay. So what I did is I dragged in the split thing, split the data, in this case 50-50. Then I dragged in a train model component. And this train model component just needs to know one thing. What is the column you want to predict? So I just tell him, I predict, in this case, the column whether it's valid or not. But then, there are a lot of different mathematical approaches. Those of you familiar with R and Python, which was quite a big group, will know about neural networks and decision trees and whatever. So how do we go ahead and tell it how to do that training? Well, for that, in this case, I'm doing classification. I'm predicting some class. Yes, you are a valid observation, or no, you're not a valid observation. So in my case, I can type classification over here. Lazy as I am, I'll just type part of this. And then you see over here the classification group. And in that group, we have a whole bunch of pre-programmed machine learning algorithms. So we can go ahead and, for instance, pick over there boosted decision trees, decision forests. Some of these might be things you're less familiar with. Decision jungles. Anybody use decision jungles? This is one of these things that Microsoft came up with. Microsoft is doing a lot of fundamental research in the field of machine learning. So you can go ahead and check their papers in many of the conferences over there. And one of these things is a sort of hybrid decision forest over there, random forest, the decision jungle. So you go ahead and have a bunch of algorithms to choose from. You just drag them in there. So what I did is, whoops, sorry. What I did is my mouse acts weird. If I click, it doesn't do anything. Weird. How do I escape from this thing? Not with the escape key, clearly. Not by doing a left click, nor a right click. Oh, nah, this is really funny. I have no idea how this thing comes. Okay. Anyhow, so this way I dragged in one of these things. And the question often is like, yeah, which one to pick? And the answer is nobody knows. There are some general suggestions you can use, but nobody knows for any data set which of these things will work best. So it's a matter of trial and error. You pick one of these, you train your model, you then go ahead and score your model, and then you see how well things go. And then you go ahead and try another one, and another one, and another one. Remember, it's experiments. Like the guys in the chemistry lab are mixing this, and they're mixing something else, and then in the long run they see which one works best. And they have, of course, some ideas on which things definitely will not work and which things might be good candidates, but they don't know up front. I mean, else medicines would not be as expensive as they are right now. Okay, so how can I get out of this one? Close down this tab. Okay, that was the way out. Okay, so let's quickly try to get back in my studio over there. Okay, go to my experiments. No, I don't want a tour. Okay, so that was, for instance, let's go ahead and use this one. So we want to go ahead and do something over here. So we go ahead and we do a train model. We train our model. When you connect the dots, you see that they are colored. Well, at least those of you who are not colorblind, they never think about the fact that 20% of the male population, and in IT, a lot of male persons, is colorblind. But nevertheless, a green dot means that you can go ahead and connect this. For instance, out of that one came a data set. And the input to this thing had to be a data set. But this thing over here doesn't need a data set. It needs a model. So for instance, let's go ahead and grab my jungle over there. There is my decision jungle. So I now go ahead and tell him, let's use decision jungles. And now this thing colors green because that expects a training, a learning technique. So we just tell him what we want to predict. In this case, we want to go ahead and predict, what was it, the class? Okay. Then we still need to go ahead and tell him that after we built the model, we want to do some scoring. So we have our score model. We drag that one in there. We score on another data set. That's my test data set that I kept apart. Then we hit the run button and this thing kicks in action. A little bit about the running. This thing is now waiting for enough compute resources to become available. As soon as they are available, it switches over here from queued to running. If you're in the commercial version, you don't have to wait that long. If you're in the commercial version, it can run multi-threaded. If you're in the free version, it runs single-threaded. If it's in the commercial version, an experiment can run for 7 days. In the free version, 1 hour. In the commercial version, you can have as many components in there as you want. In the free one, only 100 components. But hey, that's enough to get started with these kind of things. Okay, so it finished over here. For each of those, you can see how long it ran. Okay, so when I click upon these, I see it took 3 seconds to do this thing. And it took 3 seconds about to do this thing as well. Okay, we can go ahead and inspect the outcome. For instance, if I go ahead and visualize this thing, we see over here the real class. We see over here the predicted class. And then we can go ahead and try to compare them, for instance. So compare the real class with the predicted class. And if you see this thing, you know everything is fine. When it was a 0, we predicted the 0. When it was a 1, we predicted the 1. Cannot get better than that one. Okay, now, of course, you often want to know more advanced things on this, like what is the accuracy, what is the precision, what is the recall, etc. So for that, we have another component, and that is to evaluate our model. So when I pick evaluate model, I can take this result, push it in there, and now pay attention when I run again, something special will happen. The special thing is that as soon as this thing starts running, it will no longer re-execute those. You will not see a spinning wheel on those. They immediately go to a green checkbox because it remembers, it caches all the things you've done in the past. Because very often we do these things in a step-by-step fashion, every time a little bit more or a few things a little bit different. So you don't need to go ahead and redo everything. Even if you would go ahead and change something in the source, you can, for instance, say, hey, I only want to test how this split thing works. So if you right-click, you can say run selected, and then it will only run whatever is needed to do this component and not the things further down below. And from the ones above, whatever needs to be done. Okay, so by now we can go ahead and take a look over here, visualize this thing. And if you see this thing, you either made a mistake or you're on a super simple data set. Those of you who are a bit into machine learning will know ROC curves. I'll explain them to the others in a few minutes. But something that is easier to understand is further down below. Here we see the accuracy. So this model was 100% accurate. 100% of the predictions it made were correct predictions. You usually don't get that kind of stuff in realistic data sets. Okay, I hope this gives you a little bit of an idea what this thing is about. The proposal was to split it into 2 parts. This is first setting the scene. Later on we will dive a bit deeper into data pre-processing. We'll talk a little bit more about the modeling. But mainly we will go into the deployment. How can we go ahead and deploy these things after they are made? And if that's relevant to you, a little bit on how this fits with the rest of the Azure stack. For instance, we can link this with data factories. We can link this with stream analytics. We can use it in Excel, etc. You've been extremely quiet so far. I don't know whether there are any questions or remarks, or you just had a very busy day. Yeah, I can imagine. I mean, I'm really happy that you did the effort of coming over here and going through the storm and whatever. It's not a hurricane, but, well, we're not used to these kind of things over here. Okay, so what do we do? 10-minute break? 15-minute break?
Yeah, 10-minute break. And maybe for practical reasons, we have to get out of the building by 8:30.
By 8:30. Okay.
It's like a bit more than an hour still.
Yeah, well, I'll not take it that long. I mean, I still want to have the evening. Okay, so 5 to 10 minutes, not 10 minutes, let's say it's now 25, and then we get started again. If you have questions, feel free to talk to me during the break.
I have a question.
Yeah. Okay, so we saw the basics. Let's go ahead and talk a bit more about first a bit of data pre-processing. Up till now, our focus was mainly on the modeling part. And modeling is, of course, important, but it's definitely not the most important thing in a machine learning or data mining process. So there are a couple of these methodologies. CRISP-DM is one of them. If you want to go ahead and do these things correctly, you must first understand your business. What are the machine learning opportunities that we have over here? Not every business problem, machine learning is the answer. There's nothing wrong with good old OLAP and that kind of stuff. Then, what kind of data do we have? Understanding the data. And then, very important, data preparation. Because very often the kind of data that you have for a data warehouse or whatever is not always super to do machine learning upon. So in a few minutes, a bit more on that one. Then we do the modeling, on which we already talked a little bit. Sometimes you then learn like, oh, damn, I had the wrong columns, back to data preparation, back to modeling, back and forward a couple of times. And in the end, you come up with your best model. You then present it to whoever knows the business best. They see whether it makes sense, and then we can do the deployment stuff. And then start with another project if you want. Okay. So how do we get data in our Azure Machine Learning? I already showed you that we have this built-in sample data. That was super easy to use. But we can go ahead and get data in there in a couple of other ways as well. So let's go ahead and show you. So if we go to our list of data sets over here, you can tell the system, I want to upload something new. In the lower button, we can click that new button. And there you can simply say, I have a local CSV file and I want to go ahead and use that one. So in there, you have a couple of options, CSV files, tab separated files, TSV files. Some of you some of you are familiar with R, definitely, so you can upload R data files. Some of you might know Weka, which uses IARFF files. Weka is a suite of machine learning algorithms written in Java from some university down under, New Zealand. The Weka is sort of weird-looking bird that lives over there. Okay, some of you might know SVM Lite. It's also a popular machine learning product. So you can go ahead and upload one of these files. And then, yeah, for small data sets up till, let's say, 1 or 2 gigabyte, this is a good way of doing things. If you would have a bigger data set, or if your data is stored in Azure Data Lake, somebody wants to promote Azure Data Lake, so I mentioned Azure Data Lake, I get a bonus now, thank you. Or for instance, you have your data stored in a SQL database, or you have it in Azure Blob Storage or whatever, you can go ahead and upload that one as well. If we go back to our experiment, one of the components that you have in an experiment is to go ahead and import data. So when we go ahead and type import, I can drag in this import data. And over here, you see a bunch of supported data sources over there that we can go ahead and use. There is even now a nice wizard. So if you click on this wizard, you can, for instance, say, oh, I want to load data from an Azure table, from document DB. Should rename that to Cosmos DB. I'm going to kick off a Hive query, for instance, to anything that supports our Hadoop file system, etc., etc. So, for instance, one of the options that they have in preview right now is you can even go ahead and pull data from a SQL server that you do not run in the cloud, but that you run on-prem. There is this gateway thing, which is a piece of software that you need to install within your organization. And anytime that this thing wants to read from a SQL query, it puts a message in an Azure queue. The gateway pulls the message, runs the query, sends the data back. So in that way, you can even go ahead and run on top of data that you store locally. To once again speed up things, I have, for instance, over here, an example, this one over here. Oops, sorry, here at the top. So this import data thing over here, for instance, goes to an Azure SQL database. So I set up the credentials to talk to an Azure SQL database. I type a query over here. And whenever I run this thing, it runs the query and uses the results in the flow. But then we can use tricks like this. If I select this checkbox over here, use cached results, he only runs the query once and caches all this data in my Azure Machine Learning. And as long as the data doesn't change in the database, I can now run it and it runs immediately. If I deselect this one, okay, then he will really kick off the query and pull in any new data. So that caching comes in really, really handy. Talking about caching, if you go ahead and run experiments frequently, for instance, we had this experiment that we used earlier on, that we ran a couple of times, you have over here this run history thing. There is a sort of versioning system into this. So let's, for instance, pretend that I want to go ahead and make some changes to this. For instance, I want to do some extra pre-processing component over here. For instance, this thing over here. Okay, I add some extra stuff. Connect this thing with that thing over there. And run that query. Okay, that's fine. So if I would now try to run this thing again, the system remembers the old version. It has the new version as well. And if we go to this run history, at any point in time, we can see the different runs we've been doing on this. So this one is currently running, those finished at those points in time. So if you now want to, for instance, come to the conclusion that what you had yesterday is much better than what we have today, you can click on the version from yesterday. That version, you see the one without that SQL stuff over there, I cannot run it, but I can save it under a different name. And in that way, create a sort of branching in my source control over here. So at any point in time, any run you've done on any of your experiments over there is stored, is kept. And you can always revive it by saving it under a different name. And then you can do whatever changes you want with these things. Okay, once again, when you do experiments, sometimes you take a wrong turn. This way you can easily step back to whatever you were doing before. Okay, so that's the story of loading data. So once again, either we have the built-in sample data, we upload a CSV file ourselves, or we load the data from SQL, from Azure Storage, from a local file on a website or whatever. Okay, so those are the things that we have. I already showed you that for any data set that you have, you automatically have this kind of visualization to go ahead and see what's in there. If you know a bit about R or Python, we can launch these Jupyter notebooks that I showed you before. I'm still waiting for Julia. Jupyter is short for Julia, Python, R. But the Julia language is not yet in the Microsoft stack. Julia is a lot more performant than Python and R. So could be interesting if over time they would add Julia to the list as well. Okay, but then the data pre-processing. So if you have your data, there could be a lot of issues that you could have with your data. For instance, one thing is, if you do machine learning, the thing we hate most is unique values. Nobody wants to have a machine learning model that makes predictions like, if the order ID is 25, then you order product X. Because any of your new orders will no longer have product ID 25. So anything that is unique should be kicked out. Another problem that you can have is too much data. Nowadays, where storage is so super cheap, I recently read that you have now a sort of super cold storage in Azure that costs you less than €1 per terabyte per month. So storage is super cheap. So sometimes we have the problem that we have too much data. If you have too much data to do machine learning upon, your models don't always become better. It simply sometimes takes just a lot longer before your model is created. So maybe you need to go ahead and filter down some data. Maybe you have too old data. If I would look at the sales figures, for instance, or the web visits that people have to the Amazon website made 7 years ago, and I would use that to predict which DVDs they're going to buy today, that's not going to work out. You need to have only the more recent data. You can have skewed data distributions, where one class occurs a lot more often than other classes. Some machine learning algorithms have problems when attributes have different scales. If, for instance, age is expressed in value in years, but let's say an order date is expressed in days, then they have a different scale, and the system might think that the one with the higher numbers is more important than the one with the lower numbers. So these are all sorts of problems that you can have in machine learning, and where the system has built-in stuff to go ahead and help you build better representations. For instance, imagine I want to learn something about customers, and I know their email address. Email address is unique, so you don't want to have rules like if the email address of the customer is nico@utu.be, he's going to buy a bike, else he's not going to buy a bike. But you could extract features from this, like, hey, if we just take the last part of the email address, that's a lot less unique. And if your email address ends on .fr, you're probably not from the Netherlands. Okay, so we know a little bit about these kind of things. Or for instance, text mining. In the world of text mining, a sentence like this is unique. For instance, you're doing a Twitter analysis or whatever. This is unique, but what we typically do is we create n-grams of this. We, for instance, take the first two, the next two, the next two, etc., etc. So in that way, step by step, you, for instance, say, okay, I want to see all the messages in which stupid example occurred over there. So these are examples of pre-processing, and there is a ton of pre-processing things built into the system. Just a quick example. Let's go ahead and grab. Let's grab this one again. Okay, so over here, for instance, for test purposes, you can have the most stupid data source where you just go ahead and type a couple of values. Since I'm SQL Waldorf, I took a couple of quotes from the Muppet Show. Just when you think the show is horrible, something fantastic happens, it ends. One of the quotes from Statler and Waldorf. If we want to go ahead and do text mining on top of this, we should go ahead and build all these pairs of words that occur. So, for instance, one of the built-in things that we have is the extract n-gram features built in. So when we go ahead and run this and see what comes out of this, we see that it builds a data set where, for instance, it tells you where the words just and when occurred right next to each other, in which messages that happened, in which one they didn't, show horrible, etc., etc. So it goes ahead and builds all these pairs or triplets or whatever of words with, once again, a whole bunch of properties. Over here I told him that I want to see two pairs of words together, that they need to occur at least a certain number of times before they're in there, etc., etc., etc. So these kind of things make it easy on you. Now, what if you want to do something for which there is no pre-programmed component? Well, we have three quite generic components with which we can do our data pre-processing. One of them are the scripts that we can write in R or Python. So if you know a bit about R, if you know a little bit about Python, and you want to clean up your data with those, you can just drag in, for instance, an R script. This R script has three inputs. The first two of them can be data sets. So I could, for instance, take this data set, feed it into the R script. The third one can be a zip file. Why is that? Your R script can only access the default packages that are available in R. Packages allow you to extend the R language. Now, what if you have a custom-made package, or you have something on GitHub that is not in the CRAN repository? Well, sorry, you cannot go ahead and use it immediately, but you can make a zip file out of it. Upload that zip file, just like I uploaded a data set a few minutes ago, and then attach it to this input port over here. And the Azure Machine Learning will automatically unzip it and attach it to your workspace over there. You can then run your custom R code. So in here, you just go ahead and write some code. They have these special things. So this stuff simply says, whatever comes out in input number 1, go ahead and turn that into a data frame and call that data frame dataset1. And then you can do your regular stuff. You can go ahead and if you uploaded your own zip files, you can go ahead and load whatever is in that zip file in this kind of way. You can even do plot, etc. if you want, because this R component has two outputs. One output is the output where this stuff arrives. So you need to go ahead and call this function in the end with a data frame to say, okay, this is the output, this is the cleaned up stuff. But any plot statements or other statements that produce results, they are shown as well. And they are shown on this output over here. Okay, so this is your data set that comes out The second one over here is the result of whatever plot statement, etc., that you would go ahead and do. Okay, so the same thing with Python, very similar. Also a zip and two inputs that you can go ahead and use, one output that you produce, another one. Now, some of you might go like, oh, I don't know Python, I don't know R. But the person who did the introduction mentioned another language, a language that I know really well, because I do a lot of training on that one, SQL. So we also have an apply SQL transformation that you can do. With that one, again, you have now not 2, but 3 inputs that you can have. And in here, you just need to go ahead and write some SQL code. So the first input is called T1, the second T2, the third T3. And over here, you can now do your outer join, or you can go ahead and do a where clause, or sum up 2 columns with a simple plus in the select, etc. So if you know any of those 3 languages to prepare things like sums or ratios or whatever on things, you can go ahead and throw them in here. Just one slightly disappointing thing, the SQL script over here is not T-SQL. You don't have the full potential of a SQL server, because remember, it's a stream. You need to go ahead and implement this in a kind of streaming fashion. So they use SQLite for this. And SQLite does not have all the language constructs that we would hope for from time to time. Okay, so these are ways in which we can go ahead and do some pre-processing on our data. So once again, you have built-in stuff. Sometimes things like detect languages, you just go ahead and send the text file and it says, hey, I think this one is in English, that one is in Dutch. Or you can go ahead and, for instance, extract key phrases from text. I showed you the n-gram stuff, etc. So you have a whole bunch of things built in. Another example over here is, what if you have missing values? Some of the machine learning algorithms can perfectly work with missing values, and they take care of this themselves. But not all of them. So if you have a bunch of null values in a column, you can use this transformation over here. And in there you could say, okay, for instance, replace a value with a hard-coded value, replace it with the mean, the median, the mode for textual things, and the value that occurs most frequently. Or just kick out a row if there is no data. Kick out a column if there is no data. Or do some principal component analysis, etc. So you have all sorts of simple and more advanced algorithms to go ahead and replace missing values. Okay, we can filter out data. So we have a whole bunch of pre-processing options. Which one should we take? Well, nobody knows. It's a matter of trial and error again. And usually we see that the outcome of machine learning projects depend a lot more on the proper preparation of the data than on whether you use neural networks versus decision trees versus naive Bayes or whatever. So this is something where you should know the business, you should know which things make sense, etc. For instance, I have a very simple example somewhere over here. Where is that one? Here. So this is a super stupid data set again. If you take a look at it, I simply have over here some label, true or false. What is this? This is the number of items we have in stock, and this is a new order that was placed. Oh, if you order more things than what you have in stock, you cannot pass the order. Okay, so you simply need to learn that this thing should be bigger than that thing over there. That's the concept you want to learn. Now, this is not super easy for machine learning, because most machine learning algorithms look at column by column. They don't take combination of columns into account. So if I would go ahead and run this particular thing, okay, I already ran it to speed up things. You see that you have a model that is, well, not perfect. We reach about 94% accuracy, because in the background it learned rules like, if, for instance, the stock is larger than 90 and the order is less than 90, then you're good to go. If the stock is more than 95 and the order is less than 95, you're good to go. And in that way, it learns for each and every point over there, these kind of things, which is not super easy to do. But what we now could do is we could, for instance, use that SQL stuff over there. We could throw in a SQL transformation. Okay, so we had 2 columns over there. One was called stock, the other one is request. So I could now, in my SQL transformation over here, say, okay, go ahead and return not only the 2 columns that you have, but also, for instance, stock minus request, or stock divided by request, that doesn't matter, as difference. Okay. So in this way, we now tell the system that it should take a combination of the 2 columns, in this case, by using, by using the difference or the ratio or whatever, and take that one into account. And if we now go ahead and rerun this thing, we will see that the outcome is much better, because now it simply needs to learn if this difference is less than 0, then it's good, else it's bad. Or if you made a ratio, if the ratio is less than 1, it's good. If the ratio is more than 1, it's bad. So by adding these kind of things, you will see that your model becomes much more accurate. Okay, well, I'm not going to wait till it's finished. Just take my word for it. Okay, so that's how we can go ahead and do some data preparation stuff on top of this. Just trial and error. Once again, it's important to remember we don't want to learn the best model there is. We want, in a short amount of time, learn a model that is better than what we're using right now. It should be good enough. It should not be the best. Because you have millions and millions of possible data preparation steps, millions and millions of different modeling techniques with their different parameters that you can use. And you don't want to take the combination of million pre-processing with million modeling techniques and try all of them. Okay, maybe a little bit more on the modeling itself. So we already saw that when we go ahead and do this modeling, we first have this split stuff, then we do some training, then we do some scoring on top of that one. So whenever we go ahead and do this modeling stuff, we need to decide upon a certain modeling technique to use. So the Microsoft guys made it easy on us. They made a cheat sheet. This is the cheat sheet. I hope it's a bit readable. You can download it as a PDF on their website. So over here they say, okay, we start over here, and then you must first figure out what you're going to do. For instance, do you want to go ahead and predict a category that you belong to? Or do you want to predict continuous values? This is regression, this is classification. Or for instance, do you want to do something which is called anomaly detection? In anomaly detection, you only have examples of one class, and you want to predict whether a new observation belongs to that class or not. For instance, you only saw valid credit card transactions, and now you need to learn credit card fraud. You cannot first ask to the bad guys, hey, give me a few thousand examples of the kind of wrong things you do. You have to learn from one class only. That's anomaly detection. Or something that we didn't cover over here, unsupervised learning. With unsupervised learning, you don't even have any kind of examples. You just need to go ahead and create clusters, etc. So for instance, in our case, we wanted to predict categories. And then the question is 2 categories or more than 2 categories? If you go for 2 categories, next question is, do you have a lot of columns over there? Or do you have a few columns? So if you have a lot of columns, then this one and that one are good candidates. So in that way, for instance, you end up with 2 class support vector machines, or if you don't need to have that many columns and you want to have some fast training, for instance, an average perceptron, etc., etc. So you can go ahead and use this to get a couple of ideas on where to get started. But once again, there are no guarantees. It's a matter of trial and error. So you have a whole bunch of algorithms. I don't have time to go into these different algorithms over there. But what is important is that you go ahead and test them. So as soon as you learned your model, you feed in this test data for which you know the real outcome. And then you have to compare, the two. I'll quickly fast forward a little bit. And the main tool that we often use to compare things is known as a rock chart. Some of you might be familiar with this. Rock chart comes from the world of signal processing. It's receiver operator characteristics. Doesn't really matter that much. But what is important is it plots the false positive rate against the true positive rate. What does that mean? False positive rate is the number of cases where the system would go ahead and predict them to be positive, but in reality they were negative. So ideally, we don't want any of these. Ideally, we want to keep this at 0. But on the other axis, we have the true positive rate. From the ones that are really positive, how many of them were predicted by the system as positive? Yeah, ideally, you want to know that all of the positive cases are predicted as positive. So this thing over here is rock heaven. And as closer as your chart is to rock heaven, the better. So if I would have 3 models, one that goes this way, the blue one, and the last one that goes that way, I would pick the last one, because that is performing best. So for instance, if we take this point over here, this point tells me that we get 70% of the positive cases are correctly identified by my machine learning as positive, which means that 30% of the real positive cases are labeled as being negative. But to get that 70% of the true positives, we need to make 10% mistakes at this 10% over here. So that means that from the things that are predicted as positive, 10% of them really were negative. Okay, so that's the trade-off. And why is this trade-off important? Because we can go ahead and decide on the cutoff point. And this is something that I quickly want to show you. So over here, by now, I have some sort of model over here. Let's take a look at this model. Oh yes, this is too good. I want to buy something that is a bit worse. Let's go ahead and reuse, for instance, this one. This is a famous data set. These are all the people on the Titanic. And we know how much they paid for their ticket, which class they were, whether they died or they survived. To end with a happy note. So over here, if we take a look at this one, this is more difficult to predict. So over here, you see that your curve is not super close to rock heaven. This is the row of random guessing. If you're below that one, you're doing so bad that you better take the inverse of your prediction. That should normally not happen, okay? So you should be above that line over there. Okay, but if we now go to the bottom over here, we have things like accuracy. This thing is 69.8% accurate. But that is if we go ahead and put the threshold at 0.5. So anytime that the system makes a prediction, will you survive or will you die, it will not say you will survive. It will say, I think you're 45% likely to survive, which means you're going to die with 55% likelihood. But we can put the threshold wherever we want. For instance, if we only want to people that are really pretty certain to die, we put the threshold, for instance, at 20%. As soon as you're 20% certain to survive, I predict you're going to survive. Or you can do the opposite and say, oh, I only want those people that are very, very certain to survive. So I put the threshold at 80%. Only if the system predicts that you're 80% likely to survive and predict survive, and else I predict that you die. These different points are really the different points on this curve. This is the one where I go ahead and tell you you're always going to die. And this is the point where I tell you will always survive. And these are the different points in between. So what is crucial for machine learning is that you can translate points on this curve to your business. For instance, if you're predicting whether people are interested in a certain product, yeah, then you can make 2 types of mistakes. Somebody who's not interested, who gets a brochure anyhow, and then they go like, oh, there you are, the spammer. Or you can have the opposite, somebody who's really interested in your product, but he didn't get a brochure. How costly is each of these type of mistakes? And based upon that one, you can go ahead and decide upon your cutoff point. And you can literally play with the slicer over here. So if I would, for instance, put the threshold over here, I'm down to 53% accuracy, but I will miss out on very few items. Or I can put it over here, and then my accuracy goes up. Precision goes up, recall goes down. So we have a lot of different ways to count how well you're doing. And by playing with this slider, you're basically traveling on the rock curve and can try to find the point that is best for your business. Okay? So with that in mind, let's now go ahead and talk a little bit about making predictions. So over here I have this model, and this thing is going to predict whether I will survive the Titanic or not. I now want to go ahead and create an application where people, when they book their tickets, on their website, by the way, they say, oh yes, you're 70% likely to survive this trip. Do you want to book insurance on this or not? So to do this, I told you it's easy to do this in machine learning. what I need to do is I first go ahead and save this as a different copy, just to make sure I still have this original one over here. So let's call this web service. Okay. So that's this thing over here. And then I first need to go ahead and do one last run of this thing. If you take a copy, that copy has not run yet, so it needs to go ahead and do his learning over here. As soon as he's finished with that one, oh, that went fast, we have over here this option, create a web service. Create a predictive web service. And this is nice for an evening session. It then does a lot of magic for us. So what it did is, it first said, well, you learn the model. So whenever people now submit new information about their age and whatever, they don't need to learn a model anymore. So it saved the model that we had. That's this component over here. So the train model, the score model, well, we only need to keep the score model. The train model stuff can be kicked out. The splitting stuff, etc., we can kick out that stuff as well. And over here, this blue thing is the input of my web service. Now the problem is, the system makes a few mistakes. What it does over here is it says, whatever we have in this data set, and in this data set we know 15 or 20 things about the people on the Titanic, whatever we have in that data set, that's what you need to provide for your web service as well. But in my case, my model has been trained upon a subset of the features. I first use this component over here, which does feature selection, which says, hey, from these 20 things, pick the 4 most important features to learn upon and throw away the other ones. So I first need to tell the system to not build the web service on top of all the columns that I fed into this thing, but only on top of those top 4 most important things. So whatever data that arrives at this point, that's the thing that your web service should ask about. Okay, so that's now nearly good. I still have one last problem. Over here, if I would go ahead and inspect this data set, I would see that over here I don't only have the 4 properties of my customers, I also know whether they survived or not. That's one of the columns. Remember, we use that to train our model. But you don't want to ask somebody, and will you survive or not? And I'll predict whether you will survive. That's not good. So we need to go ahead and put in over here, for instance, a select, where we can go ahead and just select certain columns. Okay. So I'll go ahead and tell the system over here, from this data set, go ahead and pick a subset of the columns. And then that subset, for instance, over here, that subset will be all the columns that we have, except for, oh no, not all of those. Only, which columns is that? The class you belong to, I think this one, the fare that you paid, and the class, I forgot which the other one was. Okay, let's first need to go ahead and run this one, sorry. No, yes, cannot run it, so let's first run this one, and you have this run selected. And then it only runs this particular component over here. Doesn't run the other one. Let's go ahead and run it. Now we will see which columns these are. Okay. You see why I encourage people to ask questions, and we have to wait a lot with these kind of things. It's handy if there are questions in the meantime. But okay, we made it this far, so let's go ahead and see. So over here we picked from this thing. Sorry, this is the data set that he picked. So this data set over here contains these columns. So I'll go ahead and say all of these columns except the survived column is the one that I want to keep. So I go ahead and I select a subset of my columns. Here, select columns. Tell him now that from this one, I want to go ahead and pick these columns, and now I can pick them by name. So I basically say pick class and age, all of these except survived. Okay, and that, the result of that one, that's now what my web service should ask you about. So I have this web service input over here, my web service output over there. So when I now go ahead and run this, the system knows it should create a web service that asks my users for all the columns that we had at that particular point over there. And whatever comes out of this one, those are the results that are given back from the web service. So you go ahead and make one last run. This doesn't build your model. This is just to verify that everything over here is consistent. And then we have this deploy web service button over there. That's all I need to do. So now it creates a web service for me. And I arrive at this page. Anybody who has this key can go ahead and embed it in its post request to this web service and can start creating applications with this. If you want to give it a try, you could say, oh yeah, I'm an Excel user, so go ahead and give me a try. I want to see how this thing goes in Excel. So now over here I get an Excel file, and in this Excel file I'll be able to call my web service.
Can you read data provided by the web service into training your model?
So question is, what about retraining? If you're using the free version that I have over here, you only get 2 APIs. One API to submit a few rows of data and get predictions for that one in real time, and another one where you submit a big batch of data and you get back your results. But if you use the commercial version, you get a 3rd API, and with that one you can retrain your model. So then you go ahead and provide a file with new observations, and you say, okay, go ahead and retrain on that one. If you're in the free version and you want to do retraining, then you have to go back to your experiment and run your experiment again to retrain your model. But there is an API for retraining, yeah. Okay, so this thing in the meantime is not yet starting. Oh, here is my Excel. Yeah, let's start my Excel. While Excel is starting, you can also test it just over here in the browser. Huh? If I click this test button over here, I could say, hey, I'm traveling in 3rd class and I paid £5 for my ticket. I don't have any parent or siblings with me, and I'm 43 years old. And then goes ahead, calls the web service and says, okay, you're 4% likely to survive this thing over there. That's no good. Huh? Okay, let's first see what Excel does. So over here in Excel, we have an Azure Machine Learning add-in. And with that add-in, we can go ahead and call our web service that we have. So one of the questions I got a few minutes ago is, with the web service, is it okay to load a few sample records? That's because I'm too lazy. Now I already have a bit of data over there. You can say, no, no, you cannot include any sample data, and then people have to type all their data themselves. So now I simply tell the system, go ahead, and over here in cell E1, oh, sorry, that's over here, not over there. Okay. In cell E1, I want you to go ahead and put the results of this web service call. You click the predict button, and he now goes ahead and calls my web service on top of this. Predicting, yeah, I got it. Okay. So when I click predict over here, oh yeah, sorry, I forgot to put the range over here. Still need to tell him that this range over here is the range with input data. We click the predict button. So we called this thing, and then I still made one mistake. The mistake is that I, in my output everything. I only should output the last 2 columns, but I'm not going to change that one because we're going to be kicked out in 10 minutes. But over here, for instance, you see that this person traveling in 1st class, paying £71 for his ticket and being 30 years old, has an 81% chance of surviving this thing, whereas the other ones are much more likely to die. And now you can, for instance, go into auto predict, and then you can start playing around. What if this person, for instance, would be 10 years old? What would happen then? Okay, his likelihood of surviving dropped a little bit. But what if he was in 3rd class? Oh, yeah, then he's going to die. Okay? So with that happy note, I just want to give you a bit of an idea how you can go ahead and play with this. Maybe one last thing on those who love to program. The system makes it easy for you to implement applications. I already mentioned that making things easy is crucial to this story. So what we have as well is we have this interface where we can go ahead and, for instance, say, hey, I want to go ahead and see on these endpoints over here how we can use them, and we can test them over here. But if you go to the consume group over here, they go ahead and they spit out for you C# code, Python code, R code, Python 3 instead of Python 2 code, So if you go ahead and copy this stuff, they have everything in here, including the URL. The only thing you need to do is the API key. You cannot read this. The API key that you have over here, you have to substitute that one with the big key that I showed you on the previous page. And then you can just throw this thing in there, and you're calling these web services from Python, from C#, etc. So once again, the key story over here is making sure it's easy for people to get started with this, that you're not wasting too much time or money on doing things. That's the key to Azure Machine Learning. Okay, I guess with that we should finish up over here. Let's quickly see. Yeah, we have all sorts of built-in stuff that I didn't show you. One thing, for instance, is sweep parameters. When you do machine learning, every of these machine learning algorithms has a bunch of parameters. How many decision trees, how many split points, whatever. What you can do is you can use something called sweep parameters, where you say, hey, all these parameters, go ahead and spend the weekend trying out a whole bunch of different parameters while I'm on vacation. And when I come back in the office on Monday morning, I want to see all the parameter options that you tried, and for each and every one of them, how accurate the model was. And now I'm going to pick the best one. In the free version, you have to make sure you run within 1 hour. In the commercial version, you can run for 7 days if you want. Another thing that they have built in is, for instance, cross-validation. Those of you familiar with machine learning will know what cross-validation is about. It's more or less making more accurate predictions of how good your model is by building multiple models on top of this. So a whole bunch of things that is just built in and that we can easily use over there. Okay, so that's the stuff that I already mentioned. Very quickly, if you're into Cortana Intelligence, you can use Azure Stream Analytics. Azure Stream Analytics is this thing where you have live events coming into Azure, and you automatically apply some sort of queries on top of them. Azure Stream Analytics can be coupled with Azure Machine Learning. So you could go ahead and create a model that, for instance, based on, let's say, a sensor reading from 10 minutes ago, a sensor reading from 5 minutes ago, and a sensor reading from right now, predict whether your elevator goes down. I noticed the elevator was down in this building. So what you can then do is you can couple this with Azure Stream Analytics, so that when live data comes in, Azure Stream Analytics, for every 5 minutes, for instance, takes these values, send them to machine learning, and machine learning will predict whether this elevator will fail in, let's say, the next day. So in that way, we can go ahead and use machine learning in a streaming fashion without writing a lot of code. Another thing with which it integrates is Azure Data Factory. That's a component in Cortana Intelligence to do ETL, to extract data, transform it, and load it elsewhere, but then in the cloud. So there as well, we can go ahead and add to this machine learning activities, so that you load, for instance, a CSV file. You want to place it in your Hadoop cluster, but in between, you first send it to Azure Machine Learning to make some predictions on top of this before you dump them elsewhere. Okay, there is a clever guy who once said, everything should be made as simple as possible, but not simpler. That's more or less the idea behind Azure Machine Learning. Make sure you can very easily do these kind of things. But if you want to use super advanced stuff, we have R in there, we have Python in there. So you're not making things too simple. You can do all the advanced things if you want. But you can, in 1 hour, also do already useful things. So, takeaways. When you go home in a few minutes, after you said hello to whoever you're living with, before you turn on Netflix, that's crucial, go ahead and put this in your bookmarks. You know, if you turn on Netflix, you're doing nothing else that evening anymore. So go ahead and bookmark this stuff whenever you have a machine learning opportunity, but your boss is not willing to pay for a complete machine learning project on that one, and you are willing to spend half an hour of your lunch break, go ahead and see how far you get. You will be surprised how far you can already get in half an hour with Azure Machine Learning. Remember that it's more than just the modeling. There is a lot of pre-processing that needs to be done. Can be done with Azure Machine Learning as well, if you want. But if you prefer to write R scripts or whatever, be my guest. And remember, even if you only get a slightly better result than whatever you're doing right now in your company, If it only took you a half an hour of your lunch break, that's already an improvement. That's already a return on investment. Okay, Azure Machine Learning is easy. With that, I hope that you take the opportunity to try out the product in one of the next couple of days or weeks. If there are any questions, I'll be here for a few more minutes, so feel free to ask. And thank you for attending, and hopefully we see each other on one of the other Cortug events anytime soon. I don't know, Sammy, whether you still want to have a closing note.
Just some small notes. So in 3 weeks, we also have Data Mines Connect. It's formerly it was called SQL User Days, but since Microsoft is not only about SQL databases anymore, but they have many tools like Azure Machine Learning. They have many different tracks now as data mines. One of it is the data science track, where we'll get sessions like why should I use SQL Server from the perspective of a data scientist, or data lake analytics as your storage location of the future. Another one is advanced analytics in the cloud, Azure ML. A bit the session we got today also. Another one is DevOps for data science, and another one is big data with Azure, where to begin, concepts and best practices. These are just 5 or 6 sessions that will be given on day 2. It's a 2-day conference, and on the first day, it's a 1-day pre-cons, and that one will be given by Ginger Grant, who will talk about data science with SQL Server. There's still spots available, so if you want to go to it, go to dataminesconnect.be for the event. So thank you for all for coming, and especially Nico, thank you for giving us.
You're welcome. Thank you.